and paper, your pencil. Okay, here we have the question. Farabi, Farabi, hello Farabi, Farabi,
Welcome, sir.
Salam. Can you read this question? B1.
Explain in terms of molecules how the evaporation of water keeps the runner cool.
Okay, so here they gave three marks. What will be the 3 points? How the evaporation of water keeps the runner cool. So in evaporation, what happens? Can you write on your copy? In evaporation, more energetic molecules escape, right? So it is our first point that in evaporation, more energetic molecules escape. Hello, Nubrat. Nubrat. Write on your paper. Nubrat, what I'm writing on the screen, you write on your paper. Huh? In evaporation, this is question 6, B1, last part of our worksheet on topic 11 and 12. So we will finish it by few minutes. Then we'll start the new topic. In evaporation,
Sir,
in evaporation, more energetic molecules escape from the
surface.
surface. Yes, this is first point. And then second point,
So to give 3 points.
yeah, we have to give 3 points because 3 marks from the
So the average
surface.
standing energy decreases.
Surface. Okay. Shafkat is coming, Adnan Rahim, Zawa, they are joining. Okay. So this is our first point, and second point is this energy. The
The
energy.
average
Look, the more we are writing, more energetic molecules escape from the surface. Now this energy is coming from the liquid, right, or the surrounding body, isn't it? Yeah, here the energy is coming from the runner's body, right? This
what is the runner's body?
runner, there was one runner, he was running, right?
Oh,
Okay, we did part A in last class. Look, you forgot maybe. I am writing
no
for
sir.
the point.
Part A was
Yeah,
they they will gain standing. It was about the container.
yeah, I am showing you, no problem. Just write it, write the point, then we will see the diagram. The energy required from required for evaporation, right? I am elaborating it so that you can understand it better. The energy required for evaporation comes from runner's body. We know that in evaporation process, the energy is coming from the surroundings, right? Isn't it? Hello,
Yes sir.
because it is taking the required energy naturally. We are not giving any heat from outside, right? The energy required for evaporation comes from runner's body, as the runners uh, From the runner's body, we are getting the evaporation process. That's why it will come from runner's body. Runner is
This is
sweating.
number.
The runner is sweating, right? He is running and he is sweating, and from his body, the water is
Yes, sir.
evaporating. So the energy is coming from runner's body.
Sir,
Okay,
this is
now
number 3.
I am showing you the diagram. These 2 points are done. We will write another point. Before that, you see the diagram. Look, here is the runner. Look, we did this, 6A we did in last week, in last class. Instead, what happens to the molecules of a gas as it temperatures increases? We did it in last class. And 6B, we are starting now. Already we started. Some of you joined late, that's why I'm repeating. Figure 6.1 shows a runner in a long distance race. He tips water over himself to keep cool. Okay, the runner is feeling hot, and to become, cool down, to make his body cool, he is tipping some water. Okay, on his head. Do you understand the diagram?
Yes,
So
sir.
now they are asking you, uh, explain in terms of molecules how the evaporation of water keeps the runner cool. So our 2 points already we wrote, that in evaporation, what happens? That one we wrote first. In evaporation, more energetic molecules escape from the surface, and then we wrote the energy required for evaporation comes from runner's body. Okay, now we are writing the, now it is our common or general knowledge that if something is losing energy, like runner's body is giving heat for the evaporation process, so it will lose energy, right? Runner's body will lose energy. That's why the runner will feel cold. Is it clear? Hello?
Sir, can I explain again, sir?
Yeah, I am writing, you see. Since runner's
Sir,
body,
this is the answer of what, sir, since the runner?
this is the third point. Okay, we
The
have to
third
write,
point. Okay,
yeah,
okay.
we have to write here 3 points.
Oh,
And
okay, okay, sir.
this is third point I will write. Since
Okay.
runner's body loses heat, runner feels cold. It's happening also for us, right? When we are taking bath, that time, uh, even after rubbing the skin with towel, we have some water left on our body, right? And if we are coming uh, outside and under the fan, after some time, you will see there is no more water in your body or in your skin, right? Isn't it? Hello? Hello, you should respond when I am saying that you should respond. So
Yes, sir.
that time what happens? You are feeling little bit cold, right? In your body we get little bit cooling sensation, right? Is it clear?
Yes, sir.
The same thing is happening now. There is evaporation process, and in this evaporation process we need energy. Energy is coming from the runner's body. That's why runner is feeling cold. Is it clear? Hello? If it is clear,
Yes,
then we'll go to next point, next
yes, sir.
step. Shafkat, can you read?
Yes, sir. Yes, sir. At one point in the race, a strong breeze blows past past the runner and the water evaporates more quickly. Suggest one reason why the water evaporates more quickly in the breeze.
Okay. So in
Sir,
breeze, what
because
happens? Yeah. Say
sir, sir, the wind blows across the surface of the liquid, sir.
Sir,
yes.
as he runs, like his body temperature increases and also it becomes wind. Like
Hey, bad day.
Yes. Yes. So uh,
skis, but
if there is evaporation, then there is water vapor around his body, right?
yes,
Isn't
Yes,
it?
sir.
So if
Yes,
his body is surrounded by water vapor, that means his body is surrounded by humid, right? Humidity. Humidity will be more. So if there is more humid, we know that evaporation process will not work better. But if we are giving the breeze or wind, then what will happen? This humid will remove away, right? Or go away from his body, isn't it? Hello, hello.
yes, sir.
So I'm drawing little bit. You will understand then. Like here is the runner. I'm drawing just little bit. This is the position of runner. Okay, and when the water evaporates on his body from his body, then there will be vapor around his body like this, right? Water vapor will be around his body like this, right? Isn't it? So
Yes, sir.
you also label this thing. You also label. This is runner, uh, and the surrounding things. I am showing you the water vapor, right? I'm showing you a diagram that it will be clear to you. Runner. This is runner. And after evaporation, what will happen? Here we have water vapor layers around him, right? Isn't it? Water vapor. So if this water vapor is staying surrounded area of runner, then what will happen? It will not allow more evaporation, right? We know that if there is humidity more, then evaporation becomes slower, right? Isn't it? Hello.
Yeah.
If there is, you write, if there is a water vapor around the runner, I am writing with elaboration, okay, but in your this space you do not need to write so many things. I am writing for your understanding. If there is water vapor around the runner, uh, then evaporation becomes slower. Now, to make the evaporation process faster, what we are doing, we are giving here air blow, okay, so that this water vapor is removed from his body's surrounding area. Look, I'm drawing here. So here we are giving wind, we are giving wind we are giving. Okay, then what will happen? Wind.
Amma, ইস্পিরানো কি ঘুম গাইতেছে
So this wind will remove this water vapor from his body, right? Isn't it?
এই জায়গা মারো
Wind or breeze remove or take away vapor which makes the evaporation faster. So you got it, the whole discussion from the whole discussion? Hello?
Sir, do we need to write the last point?
This last point you will write in this space. The other things we are giving only for your discussion. You see, they asked you, suggest one reason why the water evaporates more quickly in the breeze. That means the last point is giving you the point answer. Wind or breeze remove take away vapor which makes the evaporation faster. Is it clear now?
Yes, sir, yes.
Your most important point is this one. Okay, this one is most important. The last point. That one you have to write in the space.
So this means the wind or breeze will take away the water vapor and
Yeah,
evaporation will happen faster.
yeah. Evaporation is faster. If water vapor is available surrounding in your body, then what will happen? You will feel hot, right?
Yes,
And
sir.
there is no more evaporation from your body. The water
Yeah.
vapor around your body stops the evaporation process, isn't it?
Oh,
That's
yes,
why
sir.
when the weather has more humid, more water vapor available, that time we are feeling very hot because our sweat is not evaporated. Nowadays it's happening, right? Before the
Yes, sir.
rain, before the rain it happens most because before the rain there is too much humid in the weather, and because of this humid, our body's sweat is not evaporating. Okay. If we are sitting under the fans
Yes.
or any air blow, then water vapors goes away from our body surrounding area, then we are feeling cold. Is it clear?
Yes, sir.
So, when you are taking notes, you write all these things, the diagram also, huh? So that it's coming very much real in your in your mind, in your thinking, right? So that you do not need to memorize everything. You can make it. If you understand, you can make the wordings. Okay. So that's all about our worksheet. We are done with the structured part also. We had the test on MCQ. Now you you are supposed to take one test on structured part. You have two options. Either you can take on Sunday or you can take on Monday. Which one you prefer?
Sir, which chapter, sir?
This one only structured part.
Oh, this one.
Topic 11 and topic 12. Uh, the worksheet we did on that, on structured part only, we will have the test. In Google
Sir,
Form,
what are the options you gave?
option
Sunday
gave
and
option gave either on Sunday or on Monday you can take.
Sir, Sunday last class or
Sunday,
before break time?
Sunday, the last class is practical, not that one, the theory one. We will take the theory class. Okay, I am
so
showing
then
you
for
the
Monday, sir,
routine.
Monday.
So Monday we have two lessons, theory lessons. That day also you can take.
After the break, sir, we
After
have
the
one
break.
class.
Okay, I'm showing you the routine. Okay, then you can decide. Uh, Here is the routine. So Monday we have class 11:15, then 10 past 1. Okay, are you seeing the screen?
No, sir.
No, sir.
Okay, I'm showing you. I'm showing you. Here is our routine. Uh, on Sunday we have class at 10:30. That is theory class. In that class you can take, or you can take on Monday 11:15 or 10 past 1. So which one you prefer? Which class?
Sir, Monday, sir.
Monday
Monday,
which
sir.
lesson? 11:15 or 10 past 1?
So 11
11:15.
11:15, sir, not 10%.
Okay. 11:15. That's fine. So on Monday you have test 2 on structured part, topic 11 and 12. Okay. I will write it in Google Classroom also in your group. Okay.
Okay, sir.
About the test, our decision is made final. Now we are going to our new topic. Can you see the screen? New topic name?
General web properties.
Yes. This is section 4. So from Cambridge syllabus, we are done with 3 sections. Section 1, section 2 and section 3. Section 1 was general physics. There was only one topic, that is measurements. Can you remember in class 8 we did at the beginning? Hello?
Sir, Kazi,
Yes, sir.
sir,
Okay.
I
Then
think, sir, I think the second class will be better, sir.
That 11, no, it was not 11:10, sir.
10 past 1.
From 1:10, yes, sir, yeah. From there I do think there, because there is no class after, just accounting and economics
No,
class.
sir. Take it in 11:15 because we'll be tired.
Okay, 11:50.
Down to
Sad, it's okay for you even on Sunday, right?
sir, it is a, yes, sir, it is okay, but it will be a bit congested.
ভাই স্যার
Like
তুই কি
the
2
hurry.
ঘন্টায় কি সব পড়ে ফেলবি?
আবার পড়ুন তো না, ক্লাস তো মাঝখানে আসে না। আবার অন্য ক্লাস একটু এখানে যদি সময় লাগে ছবি তুলবি, অন্য
ভাই
ক্লাস জয়েন
একটা
দিলে আবার
10-এ কে কে পরীক্ষা দেয়? একটা 10-এ পাগল না?
কি বাংলা
যাবো,
বাংলা পরীক্ষা
10-এ
দুইটা
ক্লাস।
বিষয় দিতে পারবো না। বাংলা ক্লাস বাংলা
তো
পরীক্ষা তো
অপশন
দুইটা
নাই ভাই,
আছে।
এখানে তো অপশন আছে।
ভাই সাদের লজিক একদম ভাই, বাংলা ক্লাস কি 2টা আজকে?
Okay.
দুইটা না থাক।
Okay,
Bye,
Sad,
Sad, chupchap.
Sad, can you sacrifice for them because most of them they're
আর মেজরিটি উইন।
yeah. Sad, can you sacrifice for them, please? No.
Sad has to sacrifice, sir.
স্যার
It's
মাস
not his choice, sir. He
Hello,
must
Sad,
sacrifice.
my dear Sad.
Yes sir.
মাস প্র্যাকটিস।
Hello.
Is it okay? 11:15.
ইয়েস
Yes
স্যার।
sir. Okay sir.
Okay. Okay. Now we are going to our that one. What I was saying, section 1 was measurements. You did in class 8 at the beginning. Then also we did section 2, that is Newtonian mechanics, right? In your class 8 we did both section 1 and section 2, and also we did part of section 3, that is the energy and thermal physics. 2 topics, 2 no, not 2, 3 topics we did, 8, 9 and 10, right? And now we had 2 more topics from thermal physics. We did that. We are done with topic 11 and 12. So our section 3 is done. We are now starting section 4, general waves. Waves have 4 topics: 13, 14, 15 and 16. And we will inshallah do all of them during our half yearly syllabus. Okay, then waves will be also, but in final term we will start section 5, electricity and magnetism. So is it clear, the planning and the roadmap, everything is clear to you? Hello? Hello? Students, you please respond. I am not getting response from you that much. Aisha, Adnan,
Yes sir. It is clear.
Farabi, Saad, then Nubrat. Nubrat is totally silent today. Okay. Now, general wave properties means it's related to all the waves. If the matter of waves come, then we have light wave, we have water waves, we have sound waves. All these waves are all together have some common properties. Those common properties we will discuss here in this topic. That means this is the basic or fundamental topic for waves, to understand waves and their natures, their characteristics. So this chapter is very important. You have to be regular in class, and you have to participate in class, read the notes. Today I uploaded this note in your Google Classroom, so you please have a look. At home you are getting time, you please try to have a look, then we can go faster. Now we are having this learning outcomes. I want Adnan
Sir,
Rahim.
wave, sir.
Yes, waves. This total section is waves, and we have here in waves the first topic, that is topic 13, that is general wave properties. Okay.
Okay, sir. Understood.
Now Adnan Rahim, could you please read this learning outcomes
Sir, from A to F.
from A to F, right?
Okay, sir. Candidates should be able to say A. Describe what is meant by wave motion as illustrated by vibrations in ropes and springs and by experiments using a ripple tank.
Yes.
B.
Then
State what is meant by the term wavefront. C. Define the terms speed, frequency, wavelength, and amplitude, and recall and use the formula velocity equals to frequency multiplied by wavelength.
yes.
D.
Then
Describe transverse and longitude. Sir, what is this?
longitudinal.
Okay, longitudinal waves in such a way as to illustrate the differences between them. E. Describe the use of a ripple tank to show number one, a reflection at a plane surface. Number two, refraction due to a change of speed at constant frequency. F. Describe simple experiments to show the reflection of sound waves.
Okay, so here we are getting actually the basic or fundamental properties, characteristics of all waves. Look, we have here waves from ropes, from springs, from ripple tank. Ripple tank is related to water, water ripple. Then we have here later on sound waves. We have sound waves, and we will get the differences between uh, transverse and longitudinal waves. That means all the waves mainly we are dividing into two types, uh, transverse and longitudinal. And which one is called transverse, which one is called longitudinal, why they are called transverse, why they are called longitudinal waves, we will try to understand. Then also we will have some terms here, right? Look, we will have the idea of what is called frequency, what is called wavelength. Yeah. Then we will calculate the speed or velocity of the wave from this formula, frequency multiplied by wavelength. We will also have the idea of amplitude, what is called amplitude, what is called displacement of the particles in waves. That one we are going to understand. We will have the idea of wavefront. Yeah. Then we will have the idea of reflection of waves. It's not only for reflection of light, it's also about reflection of sound. Reflection can be in the water wave also. So we will try to understand them. Then refraction due to the change of speed at constant frequency. So we'll try to understand how the refraction is happening in waves. So what is wave? First, we will try to understand what is wave. Wave is the means of transferring energy uh, in the medium, right? Or without the medium. Look, here we have the definition of waves. Propagation of disturbance that carries energy from place to place in a regular and organized way is called wave. I'm showing you one diagram that will help you to understand. Look, this diagram, huh? This one, the diagram with rope we are showing, and here one person is holding this rope, and this end, the other end of the rope is attached to a stand. So when the person is moving his hand up and down, he's creating some, he's applying some energy, right, on the rope, isn't it? He's giving some energy in the rope.
Yes, sir.
So this energy is transferring, he is giving this energy here at the first end, but this energy reaches to last. How it is going? It is going by the
In waves.
particles vibration, right? Particles vibration, and you see here the rope has some particles, right? In this place, and these particles are not actually going to last end. Particles are staying. The ropes, if you think of the ropes, molecules or ropes, atoms, they are not changing their place. They are staying in their place. But what they are doing, by the vibration of up and down, they are transferring energy to the next molecules, right? Isn't it? Hello? Do you
Yes,
understand
sir.
what I'm saying? So this is a way of transferring energy. Wave is the way of transferring energy, okay, from one molecule to another molecules of an object. Now in organized way we are writing the definition. Can you please write on your copy this definition? Can you write this definition? The first one, wave. Kazi. Hello, Kazi. Kazi.
Sir, this is from topic which from now we are doing it from which topic, sir?
Topic 13, general wave properties. And also write today's date. Write this definition, please, everyone. Kazi, are you writing? Kazi is not there. That's why no one is responding. Okay. Then Aisha. Aisha, are you writing the definition?
Yes, sir.
Please read this and write. Huh? First you
Yes, sir.
read, then you write.
Okay, sir.
Yeah, read please loudly.
Wave.
Yeah. Yeah.
Proper regulation of disturbance that carries energy from
Louder.
Say.
place to place in a regular and organized way is called wave.
Okay. Can you
Wave
read?
transfers
Wait, wait,
energy
wait,
and
wait, wait.
spreads.
Can you read again the first definition?
Um, Wave.
Propagation. Yeah.
Propagation of disturbance that carries energy from place to place in a regular and organized way is called wave. Wave
Okay.
transfers energy and energy spreads as the wave moves.
Okay. Wait here. So here we got the definition of waves. Propagation of disturbances. That means when the person is uh, moving the rope, he is creating disturbances in the rope particles or rope molecules, right?
Yes,
Isn't
sir.
it? And that disturbance is carrying energy from place to place. He started at one end in the left side, then this energy moved from place to place in a regular and organized way, right? And this thing is called wave. So please write this definition. Also write this part. Wave transfers energy, and energy spreads as the wave move. Okay, now continue. Aisha, you can continue the other part, please.
Most familiar are surface waves that travel on water, but sound, light, and the motion of subatomic, sub, subatomic atomic
Hmm.
particles all exhibit wave-like properties.
Subatomic.
Okay. Let her say. No problem. I will correct her. No problem. Look, subatomic particles means in atom the particles have we have in atom electrons, right? We have protons, we have neutrons. So this when we will discuss nuclear physics, that time you'll understand it more that how the subatomic particles they can also exhibit wave-like properties. Now just you remember that the subatomic particles they also can show the properties. More details we will have discussion in nuclear physics. Okay. Now
Okay, sir.
please continue here.
In the simplest wave, the disturbance
Hmm.
oscillates
Hmm.
periodically with a
Hmm.
fixed frequency and wavelength.
Okay, in our lab you did some experiments with spring, right? And
Yes, sir.
we used some mass at the lower end of the spring, then we pulled when we pulled the mass, then we got the vibration, right? Vibration of the
Yes,
spring,
sir.
and that vibration was periodical means it's going up and down within a uh, and following um, sequence, following a tendency, right? So
Yes, sir.
oscillation means vibration. Periodically means it's following a particular time, right? In a
Yes,
particular
sir.
time, it's moving up and down. So the upper vibration and lower vibration is making a complete period, complete cycle. One upper vibration and one lower vibration from its rest position is creating one period. So that one is called oscillates periodically, right? Oscillates periodically. Is it clear?
Yes, sir.
And we will also understand what is called frequency, what is called wavelength. That one we will go for more discussions later on. Now continue, please. From here, mechanical waves.
Mechanical wave sound, such as sound, require a medium length through which to travel, while electromagnetic waves do not require a medium and can be propaged
Propagated,
through
huh?
propag-
Propagated, propagated through
propagated
a
through
vacuum.
a vacuum.
Yes. Then,
Propagation of a wave through a medium depends on the medium properties.
so here we got mechanical waves. Mechanical waves, they gave examples such as
I have a
sound.
question, sir.
Yes, sure.
Sir, here, what is the meaning of propagation?
Propagation means moving forward. Is it clear?
Yes, sir.
So mechanical waves means they who need medium, and non-mechanical means which do not need any medium. Like light wave do not need any medium from sun to earth, right? To travel. That's why light wave is non-mechanical wave. But sound wave requires medium like air, water, or any solid. We will have more discussion in next class. Okay. Allah
Okay, sir.
Hafiz.
Allah Hafiz.